Hello guys and welcome back to CBox tutorial channel. This is our situation number 31 from CE Board Exam November 2017 for Structural Engineering and Construction. A double angle tension member 100 by 100 by 8 millimeters is subjected to a tensile load P, which is equivalent to 210 kN. The diagonal member is on a slope 2:1 and is connected to the supporting beam by UIT. So ito yung mga given na dimension ng S1, S2, S3, T1, T2, and T3. And ito naman yung mga given na allowable strength and stresses. Assume that the bolts are equally loaded. So since ang nakalagay rito ay double angle, ibig sabihin dalawa yung angle na magsasalo sa ating P na 210. So, para sa isang angle bar, ang kanyang i-carry lamang ay 210 divided by 2. So, this is 105. So, 105 kN. Okay? Ano pa ba? And yes, ang slope natin dito sa ating angle bar is 2:1. So, ang vertical niya is 2, ang horizontal niya is 1. So, kunin natin yung kanyang hypotenuse. Ang hypotenuse ngayon nito is square root of 5. Ano ba ba? Okay, yes. Ilagay natin yung mga dimension. Ang ating S1 is 38. S2 ay 75. S3 ay 100. S1, 38. Then, lahat ng thickness ay 16 millimeters. So number 1, determine the required diameter D1 in millimeters of the 3 bolts in shear connected the double angle member to the wide beam. So nasan pa yung natin dito? 3 bolts ito. Yan. So, sabi niya rito, in shear. So, kukunin natin yung ating diameter based on the allowable shear strength ng ating bolt. So, number 1, kung shear strength or shear stress, that is equivalent to shear force over area shear. So, by equilibrium, since tatlo yung ating shear forces dito, yes, take note ko lang single shear na lamang aalalahanin natin dito. Kaya hindi natin siya pwedeng gawing 6 na shear forces. So, tatlo lang. Kasi kinalahati na natin yung ating P. Okay? So, this is V, V, and V. So, by equilibrium, yung ating 3V is equivalent to P. Kaya, ang ating V is equivalent to P over 3. So, 105 divided by 3. So, that is 35 kilonewton. Okay, so kunin natin dito yung ating area shear. Kukunin natin yung area shear kasi doon manggagaling yung ating diameter. So, area shear is equivalent to shear force na V over allowable shear stress. So, ang ating shear force ay 35. So, naka-megapascal ang ating shear stress. So, gagawin natin itong Newton. Okay? So, 35 times 10 raised to 3 over shear stress na 150. So, yung ating area shear is 35 times 10 raised to 3 over 150. So, this is 233.33 millimeter squared. So, alam naman natin ang ating area for the bolts is circle, hindi ba? So, that is pi over 4 p squared. Therefore, ang ating D1 is equivalent to cross-multiply natin yung 4. So, 4 multiplied by AB over pi, then square root. Okay? So, therefore, ang ating D1 is equivalent to square root of 4 multiplied by 233.33 over pi. So, 17.24 millimeters. number 2, determine the required diameter D2 of the 4 bolts in tension connecting the wide T to the flange of the supporting P. So, dito tayo mag-focus ngayon. Pero, okay, ang ginawa kasi natin sa number 1, kinalahati natin yung P, pero dito sa number 2, hindi. Bakit? Kasi, kinalahati natin yung P2 sa number 1 dahil dito tayo nakafocus sa angle bar. Okay? So, mangyari dyan, since in top view, ganito kasi yung top view ng ating ng wide T. Ito yung element or yes, yung part, ito, yan, ng ating wide T. Diyan nakakonect yung ating angle bar. So, ito yung mga bolts natin. So, 4. So, then ito yung ating P. Okay, naka-top view kasi tayo. Ito yung ating P. So, ibig sabihin, buo ang gagamitin natin na P para makuha natin yung required diameter ng ating bolts in terms of tension. Pero, hindi lang P, basta-basta yung ating gagamitin. Kasi kung i-extend natin yung line of action ng ating P, papunta dun sa mga bolts dyan sa ating T and wide flange, yan, pwede natin malocate yung ating P dito. Okay? And as you can see here, yung ating P ay naka-diagonal. So, ibig sabihin, kailangan natin i-convert yung ating P into vertical and horizontal component. Ang tanong, anong gagamitin natin para dun sa condition ng tension? Remember, kapag tension, it's ang mangyayari, kailangan yung ating force ay perpendicular dun sa cross-sectional area ng isang member. And nakafocus tayo sa bolts. So, naka-horizontal yung cross-sectional area ng ating bolts, hindi ba? At ang perpendicular sa horizontal area ng ating bolts is yung vertical force natin. So, paano naman yung horizontal? Ang makakos kasi ng ating horizontal force is shearing. Okay? So, ngayon, masasolve na natin ang ating diameter, pero dapat ma-resolve muna natin yung ating P into vertical component. So, ilagay natin dito, ang ating P ngayon ay buo na 210 kN. So, sabihin natin ito ay PY, ito naman is PX. So, for number 2, ang ating PY is equivalent to P na 210 multiplied by, ang partner ni PY is yung 2. So, this is 2 over square root of 15. 210 multiplied by 2 over square root of 5. So, 187.83 kilo Newton. And remember, kung tensile tayo, ayan, ang tensile natin or tensile stress is 195 megapascal. So, sa ating strength of materials, ang ating tensile stress is yung sigma, is equivalent to P over A. So, therefore, ang ating A is equivalent to force P over A. Pero, ang gawin natin dito, since tensile stress naman tayo, gawin natin tensile force T. Ayan. At ang ating tensile force T is equivalent to Py. Kaya, ang ating area, this is tensile stress. Ayan. Kaya yung ating area is equivalent to tensile force na Py na 183 this is Py over 4. Bakit? Kasi, yung ating Py ay madidistribute sa 4 na volts. Okay, so this is 183.83 times 10 raised to 3, gawin natin siya Newton, then over 4 over tensile stress na 195. So, ang area natin is 235.68 millimeter squared. Okay? So, ngayon, ang ating diameter, circle pa rin naman to, hindi ba? So, ang ating diameter D2 is equivalent to square root of 4 multiplied by area na 235 23.68 over pi. Yan. So, square root of 4 multiplied by 235.68 ba? Tama. Then over pi. So, 17.32 millimeter. Ayan. Then, upon checking, kung bakit naging 14.12 to, ang ginamit nila is shear. Yan, kinuha nila yung diameter dun sa, sa shear. Okay? Nakalagay dito tension. So, siguro na, nakaligtaan nila na tension yung or in terms of tension ang pinapahanap. So, ang ginamit nila dun ay horizontal force. Okay? So, sagot dito is 17.32. Okay? Kung hindi kami nagkakamali, kasi ang nakalagay naman, kung check natin yung requirements, 4 bolts ng ating white T and sa flange na connecting supporting beam. So, dito siya. And naka-apat. At ang gagamitin natin is yung buong P. Hindi natin siya pwedeng kalahatiin Okay, kapag kinalahati natin siya, ang gagawin natin is dalawang bolts lang. Okay, ang magre-resist sa kalahati ng P na 105 kN. Okay, so buo na lang. Then divide natin siya sa apat. So tama naman yung ating analysis. Okay? Then number 3, determine the required diameter, D3 na lang. Okay? In millimeters of the 4 bolts connecting the white T to the flange supporting beam. So, nakalagay na rito required. And required diameter na pinapahanap. So, ngayon, nakahanap tayo ng isang diameter based on tension. So, ibig sabihin, kailangan pa natin hanapin yung iba pang diameter based on the allowable stresses. So, okay na tayo sa tension. So, ibig sabihin, kailangan natin makuha yung ating diameter sa bolts based on shear strength and based on the bearing stress. So, kunin natin yun. So, letter A, sa shear strength muna tayo. Or sa shear stress. So, sa shear stress, ang kukunin natin is yung Px. So, shear stress is equivalent to V over area shear, na kung saan ang ating V dito is 4. Ayan. 4 na yung ating shearing forces. So, 4V is equivalent to Px. So, therefore, ang ating V is equivalent to, dito natin lagay yung Px. So, ang Px natin ay 210 multiplied by 1 over square root of 5. .91 or 915 kN. So, ang ating V dito is equivalent to Px over 4. So, kumpitin na rin natin. Divided by 4. So, 23.48 kN. So, ngayon, ang ating area shear is equivalent to V na 23.48 times 10 raised to 3 over shear stress, which is 150. Kaya ang ating area shear is 23.48 times 10 raised to 3 over 150. So, 156.53 millimeter squared. So, gawin natin siguro to, D3 na lang. Ayan. D3 is equivalent to square root of 4 multiplied by 156.53 over pi. Or dA na lang pala. Sorry. dA. Pagtan na lang natin to. So, this is 156.53. So, 14.12. Ito. Ganyan. Okay? Ito yung sagot niya. Pero para yun sa shear tension yung number 2. So, this is 14.12 millimeter diameter. So, shade natin pero hindi pa to final answer. Isa lang to sa pagpipilian natin. Okay, then letter B. Para naman sa bearing stress. Sa bearing stress, ang bearing kasi ano rin sigma, pero may nakalagay na P or B. Yan, so masanay ako sa B. Is equivalent to bearing force over bearing area. So ang ating bearing force is 4. 4 din siya. Okay, so 4 bearing forces is equivalent to ang makukos rin ng bearing contact sa ating bolts and sa thickness ng ating wide T is yung PX. Okay? Hindi yung PY. So, this is equivalent to PX. So, ibig sabihin, ang ating PB is parehas lang, ito, 23.48. So, parehas lang sa ating shear force. Ayan. Pero, magkaiba sila ng bearing area. So, anyway, kunin mo natin yung bearing area. So, bearing area is equivalent to PB na 23.48 times 10 raised to 3 over bearing stress. Ilan yun? 1.2 of FU. So, 1.2, ang ating FU is 400 megapascal. Kung hindi nakakamali. Ayan. So, ito yung ating bearing area. 23.48 times 10 raised to 3 over 1.2 times 400. So, 48.92 millimeter square. So, sabi ko nga sa inyo, iba na ang bearing area sa ating shearing area. Kasi ang ating bearing area is equivalent to thickness multiplied by the diameter of the of the bolts. Okay? So, this is D3, dB. Yan. dB. So, makukuha natin ngayon ng dB. So, dB is equivalent to area bearing over thickness. So, wala naman tayong problema sa sa thickness kasi lahat naman sila 16. So, area bearing 48.92 over thickness na 16. Ayan. Okay, so 3.05 or 3.06. Okay, naka-divide naman to ng 4, no? So, tama naman siya. So, napakaliit naman ng diameter na to na required para sa, sa bearing, no? Anyway, ang area kasi na nakuha natin is napakaliit din naman, no? 1.2. Ayan, okay. So, anyway, sheet na rin natin to. Ayan. Okay, so ngayon, tatlo yung pagpipili natin. Yung ating diameter sa tension, diameter sa shear, and diameter sa bearing. Pero, in terms of dimension, okay, or mga sukat-sukat, hindi tayo pumipili ng pinakamaliit. Kasi, parang ganito lang. Expect lang natin na, kuwari, kamay. Ayan, kamay. 1, 2, 3, 4. Ayan. Pagpipiliin tayo na na pabubuhatin tayo ng na mabigat na force. Anong gusto mo? Mas malaking kamay or mas maliit na kamay, di ba? So, syempre pipiliin natin is yung mas malaking kamay para masigurado tayo na kaya natin buhatin yung ipapabuhat sa atin. Parang ganun lang yung idea niya. Okay? So, remember that kapag strength, ang pipili natin is pinakamaliit. Pero kapag mga dimension, mga ganyan, ang pipili natin is yung pinakamalaki. Okay? So, therefore, ang ating D required or yung D3 natin is equivalent to 17.32. Since siya yung pinakamalaki ang diameter. Oh, and by the way, upon checking, nagkamali ata kami ito ng tingin. This is 187.83 pala. Ayan, 187.83. So, 187.83 times 10 raised to 3 over 4 divided by 195. Ayan. So, ang ating area ay 240.81. So, 4 times 240.81 over pi, ang ating diameter ay 17.51. And so, correct lang natin to. So, 17.51 51 millimeter diameter. And therefore, ang ating D required is equivalent to 17.51 millimeter diameter. Yeah. Okay, so this is for number 3. Okay, so this is our situation number 31 from CE Board exam, November 2017 for Structural Engineering and Construction. So if you enjoyed and learned from these video tutorials, please subscribe and hit the bell icon for notifications and updates on our YouTube channel. So, thank you for watching. Bye-bye.